Okay, this is the basics of calculus, the mathematics of change. Going up a hill and down into a valley and then back out. At the bottom of the hill, we are looking up as high as we can. Once we get to the top, we're looking even with the horizon. So if we're looking up as high as we can, we're going to note that by a high mark on the second graph. The point at the top, where we're even, we are neither looking up nor down. So that we mark as a 0 point down here. And again, when we're at the bottom of the hill, we are going down as fast as we can just before we start slowing down to move in the direction of the horizon. So we're going to mark that by a low point because we're moving down as fast as we can. And so on and so forth. The bottom of this one, we are neither looking up nor down. And over here, we are looking up as high as we possibly can, which correlates to this spot. So if this is our height, this is the time, then this is a graph of our height according to time. This, being derived from that, is the derivative of this. This is a change in height according to time, which is the vertical velocity according to time. So the velocity starts off high, goes down to 0, goes down to negative, goes up to 0, and back up to the highest point. So down here we have the second derivative, which is taking the same thing. This is looking even with the ground, so that is neither above nor below ground. This here is at the ground level, but we are looking down as hard as we can. So that is a low point, and so on and so forth. That's calculus. This is physics. If your height is in meters, your velocity of your height is in meters per second, your acceleration is in meters per second squared. And that's the basics of calculus and physics.